My name is Ian, and welcome to my presentation on carbon capture and CO2 scrubbers for chemistry and society. This presentation investigates our impact on the Earth's carbon cycle from industrial power plants. What are some ways we combat this currently, and some new research that is being done to improve our existing methods. As discussed in class, carbon is and has been continuously cycled through our environment and the atmosphere. As we breathe, defecate, and die, we are releasing carbon into the atmosphere, and the Earth, as plants, absorb the carbon through photosynthesis. Plants are then eaten by animals, and the cycle starts again. Some of the carbon in dead plants and animals, especially in our ocean, are trapped underground and therefore taken out of the carbon cycle. After millions of years, this carbon becomes oil. This cycle worked for a long time, until humans started digging up and burning the carbon that was in the ground, coal, oil, and gas, as well as chopping down trees. In this way, we started releasing more carbon into the air while destroying what was taking it out, throwing the carbon cycle out of balance. I investigated the release of the carbon from industrial plants and how to minimize its output of the carbon byproducts. Here we see what happens to the carbon taken out of the ground. In industrial power plants, the carbon input from the ground, in this case coal, is burned in a large furnace in order to heat water into steam. This steam flows through a turbine to produce electricity for millions every day. The problem is in the combustion of carbon. We are not only creating the necessary heat, but also flue gas. Flue gas contains carbon dioxide, water vapor, sulfur oxide, and nitride oxides that are found in dirty coal. This flue gas then travels out of the furnace, through the smokestack, and into our atmosphere, unbalancing the carbon cycle as mentioned before. A single 500 megawatt coal-fired power station puts out roughly 10,000 tons of carbon dioxide each day. So what does this all mean for us? Well, when the carbon dioxide molecule is in orbit, it can absorb infrared radiation given off by the sun that is trying to escape the Earth's atmosphere without breaking apart the carbon dioxide molecule. The molecule then relaxes to its original levels, re-releasing that absorbed heat energy back towards the surface of the Earth, creating what is called the greenhouse effect. The greenhouse effect is necessary for life on Earth, and without it, the climate would be too cold for most to live in. The problem with this system is when humans start adding too much of these greenhouse gases, such as carbon dioxide, we have more radiation being absorbed and re-emitted, effectively warming our planet higher than normal. A hotter climate globally has far-reaching effects such as melting polar ice caps, rising sea levels, shifting precipitation patterns, increased precipitation, migration of animals, and much, much more. So now that you've been recapped on why too much carbon dioxide is a problem, I want to look at how we can reduce its emission in the industrial sector through a process known as carbon capture. Carbon capture is a three-step process that traps carbon escaping industrial power plants. The first step is the actual separation and trapping of the carbon dioxide through use of carbon scrubbers. The second is the compression and transportation of the carbon dioxide. Then finally, the storing of that carbon dioxide somewhere away from the atmosphere. To accomplish the first step, there are multiple methods, including post-combustion carbon capture, pre-combustion carbon capture, and oxy-fuel combustion. My presentation focuses on post-combustion carbon capture because of its use in fossil fuel burning plants. In the post-combustion method, carbon dioxide is separated from the other molecules in the gas by passing through a carbon scrubber in industrial smokestacks before it is released into the atmosphere. Currently, the most popular solvent used as a carbon scrubber are amines, such as monoethanol amine, because of its properties that allow it to bind easily with carbon dioxide and can later be separated with heat and reused for the same process. This method is useful as older power plants can be retrofitted to use post-combustion carbon capture easily without redesigning the entire facility. Here we see the reaction between the amine and carbon dioxide, where the carbon dioxide has been effectively absorbed. Later, these compounds will be blasted by steam until they heat up enough to release the carbon dioxide and revert back to the original amine. This process does, however, present some problems. Number one, it requires a lot of energy to separate the amines from the carbon dioxide with heat once it has been absorbed. Number two, it requires a lot of energy to then compress the carbon dioxide gas for transportation. And number three, the process requires somewhere to store the carbon dioxide once it is processed away from the atmosphere. This traditional process diverts roughly 30% of a plant's power output to remove carbon dioxide, and that has serious costs that businesses don't want to pay. But alas, there is hope. MIT researchers have been investigating a more energy-efficient way to separate the carbon dioxide from the amine. Instead of traditionally blasting the sample with steam, they introduce a metal that amines would rather bind to than the carbon dioxide. With a flow of electricity, they can create a voltage across two copper plates, the same way a battery has a positive and negative end. After the amines capture carbon dioxide from incoming flue gases, the solution would flow between the two copper plates, which have grooves of exposed copper. Because of their chemical properties, amines and charged copper anodes have a strong attraction to each other and form a tight bond. That causes the amines to release the carbon dioxide, which is then captured in a separate vessel. The researchers also propose the carbon dioxide gas can be sold to drillers to pump into oil wells in order to bring up more oil and thereby cover some of the costs of this process. The researchers found that this method, there was a 90% capture of carbon dioxide and cost $45 to $55 to capture one ton of carbon dioxide, as opposed to $61 in current systems. Also, this method requires 25% of the plant output compared to the 30%. Although a better system than the traditional method, the problem with this is that it still requires energy, although to a lesser extent, and still requires carbon dioxide to be compressed in order for transport. So I did some more research into carbon scrubbers and found another way to absorb the carbon. Students at Michigan State have created a new carbon dioxide scrubber to be used in industrial smokestacks that not only captures carbon, but binds it in a solid form, making an undisclosed construction material while still allowing the liquid to be recovered and used again. Now the carbon dioxide no longer needs to be compressed to transport or stored underground, resulting in a cheaper, more energy-efficient way. In their process, a smokestack packed with glass beads has the solvent poured down, while the carbon dioxide gas rises through it. When the gas reaches the top and escapes, half of the carbon dioxide has been absorbed into the liquid. Of course, every method has its downfalls. The problem with this system is that it cannot absorb as much carbon as the traditional method, which does recover 90% of the carbon emission. But the students plan to patent the method and have a deal to run a pilot plant to achieve real-world data in order to improve their method. Although carbon has been directly linked to world global warming, industry has a problem with carbon dioxide capture because it's an added cost without direct benefit to them. Sadly, if carbon dioxide capture has become widespread, more research will have to be done to convert the carbon dioxide to usable material capable of selling for profit. Hopefully we will see more research like at Michigan State and MIT to help combat the rising concern of global warming and keep our planet healthy. Thank you.